Hello everyone, in this video we will understand the secret behind working of a machine learning model. Let us look at the housing prices prediction problem. Given these prices for different areas, can you guess the price if the area is 9600 square feet? Take a moment to pause the video and try to guess it. Well, I'm sure you would have guessed the price is $8,000. How did you guess it? How did you arrive at this number? Well, the price doubles for every twofold increase in the area, and that's how you arrived at 8,000. But let us look at this in a more formal fashion. Here we have plotted area on the x-axis and price on the y-axis. If we look at the points, they form a straight line. Thus, the price for 9600 square feet would fall on the same line and it appears to be $8,000. Thus, we can fit a straight line for the given data, or we can say that our model in this case is a straight line. This model is one of the simplest model known as linear regression. Now, what exactly is a model? A model is just a mathematical function which is represented by an equation. Remember, however sophisticated the model is, it could be a deep learning model, it could be any complicated model, but at the end of the day, it is just a function, and the function is represented by an equation, and we can see a few equations here. Similarly, in mathematics, any equation could be represented by lines. Okay? It could be an ellipse, it could be a hyperbola, parabola, or any nonlinear function. So these two concepts help us understand what is a model. So all we need to do is to find a function which represents our data very well. Now, how do we choose the correct function given that there are so many functions available? In this example, we can choose the line represented by function 1 because it passes through these three lines, or we can choose function 2. Why not? Why we are not choosing function 2? We are not choosing function 2 because it does not pass through any of the data points. Hence, we can say that we will choose a function which passes through all of the data points or most of the data points. Let us look at another example. In this case, there are 5 data points. We can have 2 different lines, function 1 or function 2. Here, we can choose function 2 because it passes through more data points when compared to function 1. Thus, we can choose a function which passes through maximum data points. That is how we can say we choose a model. Now, let us look at another example. Here we have many data points, and I'm sure that there is no single line, straight line, which passes through all the data points. However, there are plenty of straight lines which passes through some of the data points, as we can see here. Now, how do we choose the correct function or the correct line? Let us consider a function represented by red line as here. This line, interestingly, does not pass through any of the data points. However, this line is closer to most of the data points. What do we mean by closer? Let us look at this in more detail. Consider a point where the area is 3800 and the price is 4100. This is the actual value present in our data. Now let us look at the point on the red line for the same area of 3800. The price for this area is 3700, which means this is the value returned by your model. This is the prediction value. So if we say the area is 3800, our model will return a value of 3700 because our model in this case is a straight line which passes to this point. We can observe that there is a gap between the actual and the predicted value. We need to minimize this gap because if our model has to be accurate, the actual value and the predicted value have to be close to each other. In this case, we can see there is some gap. The difference between actual and predicted value is known as error measure. But please note that the difference here does not mean subtraction. There is some formula behind it. There are different measures of error. Namely, we have root mean square error, mean absolute error, and there are various other measures. And our goal is to minimize the error measure. Our goal is to select the model with the least error measure. That is how we select a model. To summarize, a model is just a math function represented by line, and all we need to do is to find the function which minimizes error. That is how we find the best model. That's all for this video. Thank you for watching.